Welcome back to Summarize Science. AI that creates images from text is everywhere, but have you ever wondered how it learns? It trains on massive datasets, but what if that data is private, spread across millions of phones, and can't be collected in one place? That's the exact challenge this paper, Federated Flow Matching, sets out to solve. The core idea behind this kind of AI is learning to turn a canvas of random static into a detailed image. It does this by following a flow, which is basically a step-by-step path from noise to the final picture. Now, the straighter and more direct that path is, the faster the AI can generate a new image. A winding, curved path takes much more time and energy. The privacy solution is called federated learning, a technique where the AI trains on data from many different devices without that data ever leaving your device. The problem is, finding the straightest path usually requires seeing all the data at once, which you can't do in a private, federated system. The researchers propose three solutions, starting with FFM Vanilla. This is the simple baseline where each device trains on its own, but this results in those slow, inefficiently curved paths for generation. Their next method, FFM Lot, is a big improvement. Here, each device works to find straight paths for its own local data, which is much better. However, if the data on two phones is very different, their locally straight paths don't combine into a globally straight one. This brings us to their star contribution, FFM-GOT, which stands for Global Optimal Transport. This method is incredibly clever. It uses a shared mathematical coordinator that helps all the separate devices align their paths. This allows them to learn a single, globally straight path from noise to image, all without ever sharing any private data. Looking at their visualizations, you can see the difference clearly. The paths from FFM-GOT are much more direct and efficient than the others. This translates to superior performance, especially when you want to generate images very quickly using just a few steps. Remarkably, FFM-GOT was so effective that in some tests, it even outperformed a traditional model that was trained on all the data in one central location. So, to recap the important points, we can train generative AI on decentralized, private data. Standard federated methods are slow because they create inefficient, curved paths. But the new FFM-GOT method coordinates across devices to learn globally straight, efficient paths while maintaining perfect privacy. This is a huge deal because it means we can build more powerful and efficient generative AI without compromising user privacy. Imagine powerful, personalized AI models running directly on your phone, trained on your data without it ever going to a server. This could also be a game-changer for fields like healthcare, where models could train on sensitive patient data from multiple hospitals without that data ever being shared. It's a huge step forward for creating private, efficient, and powerful AI. Thanks for watching Summarize Science.